All right. So, if we don't limit our equations to being on the interval of the unit circle, what ends up happening with our answers? Yeah, and how many? Infinitely many. Coterminals. It's the cycle, it's the song that never ends. So, the problem becomes, if we don't put them on an interval, now what do we do? So, there's actually a way of doing this that we will get to in a second. You really just need the title, and if you want, you can find all angles and coterminal angles, and you can put, like, there's infinitely many. Yeah. The problem is, I'm going to be here for the rest of my life. Alright, so we've got to find all of the potential solutions for these. Alright, which one do we want to start with? The tangent one? Alright, so we did one just like this yesterday, right? Yeah. Actually, we did pretty much both of them yesterday. So, we ended up square rooting both sides for the tangent squared, and we're left with tangent of x equals positive and negative 1. Right? Michael? So, close. What we're going to do is we're going to say, okay, our solutions from yesterday were pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right. Do we notice a pattern? They're all odds. And so I've added 2 pi over 4 each time, or half a pi. So the easiest way to do this when you write your final answer and it's not on an interval is x equals pi over 4 plus or minus. This is what you are adding and subtracting each time. Pi over 2k. All right. So what it says is rotate another 90 degrees, then you've got another one. Rotate another 90 degrees, then you've got another one, and it just keeps going. All right. How do we feel about that? That's just the answer. Yeah. So instead of listing the 4 that are on the unit circle, you would just start with that first one and go, okay, I'm adding 2 pi over 4, while 2 pi over 4 reduces to pi over 2, and I can just keep adding as many times as my little heart desires, and I can keep subtracting as many times as my little heart desires. All right, you want to try the sign problem with a neighbor? Yeah, move the sign and then factor. So it would be sine squared of x minus sine of x equals 0. Yes? So, the one on the left is just whenever sine of x equals 0. When does sine of x equal 0? 0. And then pi. So we would write this one as being x equals 0 plus or minus pi times k. K is just however many times you want to do it. All right, so the reason it's plus pi is because I need it to go from 0, pi, 2 pi, 3 pi, 4 pi, blah, blah, blah. This one, I've got sine of x equals 1. Where does sine of x equal 1? Yep, 90, which is pi over 2. Does it happen anywhere else on that unit circle? No. So when we write this, we're going to write it as pi over 2 plus or minus 2 pi k. Because you have to do an entire rotation on that unit circle just to get back to that answer. Not the end of the world. Yeah, it's one minor tweak from yesterday, and it's not that bad. No, the proving task tomorrow is straight proofs. The proving task on Tuesday is going to be this stuff. Yes, you do get to use your purple sheet on the proving task. Do you guys want to do this one or this one on the calculator? All right, so grab out a calculator. I've got a charging cord back there. I know, but I've got a charging cord for the calculators back there. All right. Not optimal. All right, so you got that written in on your notes? All right, so what mode should our calculator be in? Radians. Calculator. I'm in radians. I've got 2x. So my recommendation when you plug it in is each side of the equation is its own line on here. Okay? All right, so what was that interval we're looking at? So 0 to 2 pi. So we need to change our window. Let's make it -1. You can actually type in 2 pi right here. And then what do we want to change our scale to be? I don't know, like pi over 4 or something? Second pi divided by 4. And then we are probably not going to need such a big y. So, yeah, let's just go 5. Not 55. Yep, so then we're going to graph it. So, I only have these 2 intersection points. Yes? Now, I know it looks like there's going to be another one over here, and it's probably because there is going to be another one over there. But, remember, I only care about the interval from 0 to 2 pi. So, if it's not from my y-axis to the right side of my graph, it's not one of the solutions I'm looking for. The red line is 2. All right, so like on mine, because it's color, blue is the left side of the equation, and the red is the right side of the equation. You see it, Mers? Okay. So do you guys remember how to find intersections on the calculator? Not trace, second trace. All right. First, second, make sure your two little bugs are close to each other, and it'll give you one here. So that's at 2.77. Perfect. That's all there is to it. 114. So one of my answers is when x equals 2.772. And then my other one is over here. No. It gave you a solving interval. So I only care between a certain subset. The words. Easy peasy, lemon squeezy? Yeah. Cool, I'm done.